Professor Oshan, for inviting us here today. I believe I'm recording. So hello, everybody. My name is Juan Martinez. I know we just had lunch and I'm ready for a nap too. So I'll try to bring a little bit more energy to my presentation. As I mentioned, somebody mentioned, I'm from the Columbia University. Specifically, I'm from the Center of International Earth Science Information Network, or what we like to call CESIN. CESIN is a research center that is part of the Columbia Climate School. And today I'm here to talk about a project which is called the Science Score Heuristics for Open Science Outcomes in Learning, or SCHOOL. The SCHOOL project is part of the Transform to Open Science initiative by NASA. And we're one of the many projects involved in this initiative. Okay, so I'd like to just start with the NASA's very own Transform to Open Science Code of Conduct. And I'd like to start here because this code of conduct reminds me of a lot of the reasons why we're all here. We're not only here to talk about computers and data, but ultimately all this stuff that we're talking about has to do with people and has to do with how these technologies will benefit humans and help our societies become more equitable and more inclusive. So this code of conduct, it's kind of my personal reminder as to the whole point of this. I'll leave it up there just so you can take a look. And I'm sure we'll share the slides later. I'm not going to go through these. But as I mentioned, let's just all remember the reason why we do what we do is for our communities and to help our globe in the greater sense. So what is NASA's Transform to Open Science, or what I refer to as TOPS? The TOPS team had a vision, which is envisioning a future where scientific discoveries are not individual efforts, but rather a collective, inclusive efforts that will generate better and faster major scientific discoveries. And for this vision, the TOPS team generated a mission statement, which is to try to inspire and empower scientists and researchers to embrace open science within their own workflows and practices, so that it enables positive change, leading to more equitable and impactful scientific ecosystem. Specifically, for us in particular, we're talking about the data science lifecycle. For this mission, the TOPS team came up with three strategic objectives, which you see here at the bottom. The first one is to accelerate major discoveries, broaden participation for historically excluded and underserved communities, and to increase the understanding and adoption of open science principles. One thing that I've noticed is that we all have a different understanding and a different definition of what open science means. So this TOPS initiative aims to get scientists and researchers more aligned and trained in open science principles, as well as to show them how to apply this in their own research. So this wheel is a conceptualization of what open science means for TOPS. The three main components are accessibility, reproducibility, and inclusivity. They are very similar to the FAIR principles that many of the presenters have already talked about. And within these three components, we have other subcomponents that we've discussed already. Some of those: open data, open software, how to increase collaboration, open tools, open frameworks, as the OGC mentioned, some standards, creating standards that we can all follow. And the reason for this framework, the offering for researchers, is that their research can be cited more. The research can have a broader reach, a bigger impact, and it can become more inclusive. In order for this to happen, that means that any research project should aim towards becoming more collaborative, and and be aiming as well to open up the workflow from the beginning, and not just when the researcher believes that the data is ready for prime time, as some would say. This also requires more equitable systems, which perhaps currently are not in existence, or that I hear we're starting to develop in many areas of this ecosystem. And of course, this also requires increased participation by several stakeholders, not just data scientists, but also decision makers, policymakers. And so it involves more than just data scientists and researchers. And so to summarize all of this, what TOP is trying to do, I think this quote here is pretty useful, where the quote is, "We need more people, more hands, more eyes, more brains with diverse experiences to participate so you can ask the best questions and find the best solutions." This is pretty encompassing of what we mean when we say inclusive. Well, why would we want to be inclusive? What's the whole point of this for the researcher or for these organizations or stakeholders? And one of the reasons is that it will bring better questions and it'll bring better solutions for a more wider audience and for more people. So with this Transform to Open Science initiative, NASA launched what they call Open Science 101. Open Science 101 is a set of 5 modules that are already live for the public to use. You can go online to openscience101.org and start signing up. And there are 5 modules, and for each of these modules, you can earn a badge at each level. And then if you complete the 5 badges, NASA will send you a certificate and a nice little badge that said, congratulations, you completed the Open Science 101 training. This is one major initiative that NASA is trying to do to train more scientists in open science. And their goal is to train about 20,000 researchers and scientists in 3 to 5 years, I believe. And so the way that the module works is, as I mentioned, there is 5 of them. The first one all the way to your left is the ethos of open science. And this module is all about the basic concept of open science, reviewing what FAIR principles are, what CARE principles are. And so it's just kind of like a general overview of the ethos of open science. The other ones start diving deeper in how open science will look within this data science ecosystem. So for example, the second one will talk about open tools and resources, which will show you how to use open source popular tools, some of them but we've already discussed, such as Python and GitHub. Another module discusses open data, how to cite correctly, how to give the proper credits, and how to get your data into repositories or get your data ready. Another emphasis here is metadata and how important it is to include that metadata. For the researcher, again, as I mentioned at the top of my presentation, this will increase their visibility and their usefulness for their data. So there is an incentive for researchers as well. And of course, the other 2 are about open software, how to make your software available to people more easily. And so that software lives in an open source repository that people can access it so that they can reproduce some of your workflow. And finally, what does it mean to share results, and how are those results considered quote unquote open? So where are these results getting published? What kind of journals are you using that are increasing accessibility, findability, reproducibility, and all these other principles that we're talking about? So these are the 5 kind of 101 open science modules that NASA has already published. So the idea is that once you have that basic training of Open Science 101, there are several projects. One of ours is included, which I'll talk about in a few minutes. And that is part of what they call the top science core. The science core is kind of like the next step after Open Science 101. And so the science core curriculum is attempting to apply those open science principles and all the lessons from Open Science 101 and show them in a reproducible scientific workflow that shows people how to best practice open science within research. We're one of a few or one of many projects within the Science Core that are producing different kinds of projects. But these projects are all facilitated through ROSES funding, which is publicly available. Any of you can apply to that type of funding. So if you're doing a lot of great work in terms of open source software or open source data, there are a lot of opportunities under the ROSES funding that is accessible. So that's kind of how we got involved, was through these ROSES opportunities. And our proposal was to develop curriculum in the form of modules that will be accessible through GitHub and leveraging these open source technologies like Jupyter Hub, Quarto, and the GitHub pages as well. So of course, I'm not part of the NASA TOPS team, but I did leave some links in my presentation in case you're interested in learning more about some of their efforts. Now, I will talk about a little bit about the specific project that we're working on, which is the school project. And these are some of the organizations that are involved in this project, including NASA CDAC, which is the Socioeconomic Data and Application Center, CEASN, as well as iSciences and the CUNY Institute for Demographic Research at Baruch. So the school project, the main objective is to develop a curriculum for Science Core, for the top Science Core, that incorporates NASA's Earth Science applications, NASA's Earth Science data, and kind of develops use cases to demonstrate how these open science principles can be applied into the data science lifecycle. Each of these modules is designed to be about 2.5 hours, and there will be both for online or in-person instruction. Right now, we're developing the modules as self-led modules that will live in GitHub, but we are working with other ROSES recipients to design more in-person instruction and to design material that will accompany these modules, but in a more kind of workshop setting. The modules will focus on demonstrating the data science lifecycle within varying themes of water resources, which was our first module. It's available for you all to see already. Currently, we're working on the second one, which will talk about health, air quality, and environmental justice. And then within the next few years, we'll develop the other modules about disasters, wildlife, agriculture, and climate. And so within these modules, as I mentioned, I'm from CEASN, and we manage the NASA's socioeconomic data repository. So within these data science life cycles and these themes of Earth science, we're also implementing a factor of population and infrastructure. So these case studies will kind of bring together different data repositories that not only talk about data Earth science, but also population and population dynamics. That, of course, as we all know, in terms of climate change and how humans impact the environment, it's becoming a more and more important topic and factor to consider when making these case studies. So this is the structure that each module will take. As I mentioned, the idea of each module is to demonstrate the data science lifecycle. and how open science can be integrated within within this life cycle. So each module will demonstrate how to collect and generate data, process it, manage it, visualize it, and then share it, all while tapping into these open science and open source principles from the Open Science 101 lessons. We're also trying this project management style called Agile, which I know a lot of you are laughing. I'm laughing too, because the jury's still out on this style. There are some pros and cons of this style, but one of the things that we have kind of that came out of this for us is that early in our development process, we're already involving subject matter experts and users to provide us feedback and to better improve our modules. So the development process has been quite a challenge because of that, because a lot of voices and a lot of feedback. So we're still trying to figure out how to deal with this agile process that, while in theory it is very inclusive, it proves to have a lot of challenges as well. So as I mentioned, we have a development team that is primarily seasoned. You can see some of the folks that are working on this, as well as some of the iSciences folks and the CUNY Institute for Demographic Research. For the first module, we developed some data sets, or we selected some data sets that are open source. These are some of the data sets that we'll use as our case studies to demonstrate how to download them, use them, and derive some sort of information or come up with some sort of conclusion. These are just a few of the examples that we will be using for these modules. Some of the technical frameworks that we'll be using in terms of coding languages. I'm sure you're all familiar with some of these. Quarto is the main one that we'll be using because it allows us to render some beautiful pages on GitHub that are very user accessible. At the same time, those same pages can be used by much more advanced developers to bring into their own environment and test or play around with them as they wish. So these are some of the technical frameworks that we'll be using to facilitate these modules. As I mentioned, we will be putting all the modules in GitHub. I left this here for y'all if you want to check out what our GitHub looks like, and it'll provide links to all the modules, and all the information will be stored in this GitHub repository. Some of the recent milestones, we did a forum at the iGuide 2023, where we had subject matter experts on water and water resources provide presentations, and those presentations were the basis of our module. All of our information and our presentations, all of our material is being housed under Zenodo. We created a community, and Zenodo is a great tool. We were talking about versioning and how to keep traceability of all these materials. Zenodo has a great versioning system. We also are using YouTube because it's so popular, and it's a great way for us to share links and our videos quite easily. So all of these tools we're leveraging to then implement into our Quarto documents and our Quarto pages so that the user has an easier way to find them. Another way in which we're using, as I mentioned, we're developing GitHub pages. And so right now we have 2 GitHub pages available. One of them is for our main project. And then the other one is our first module, which is in beta. It talks about water and how these data sets that I mentioned can be used for these science projects. Next, we'll be developing health and air quality. These are some of the data sets that we'll be using. If anybody has any ideas or has data that you're working on that you would like to propose, please let me know. We're always looking for collaborators and data sets that we should be using. Skip this one. And then lastly, we are doing a panel on AAG 2024. It'll be online. We're doing it on the health and air quality and environmental justice module. And again, we'll have some subject matter experts discussing these topics. This forum will be the basis for our second module, in which we'll develop the case studies. So with this project, some opportunities that we learned about open science. Open science seems to have a very high interest within the community right now. I mean, we're all here, and there are many other communities that are also working on this. So that's one of the benefits that I'm seeing, is that everybody's kind of very excited about what this could be and what it could mean. The Agile project management increases a wider variety of stakeholders, technologies that I mentioned, GitHub, 2Y2C, which is a kind of like a environment that is set up online, so people don't need, you know, a lot of computing power. Will help us facilitate this open science principles online for people that don't have access to, you know, large computers or supercomputers, or cannot download the data. And then early feedback from the modules, while it was very challenging to deal with all the feedback, it has made our modules much more better and much more robust in terms of accessibility and findability. So that is keeping us honest and allowing us to produce high quality work. And lastly, some of the challenges. Interpretation of open science varies. You know, we all think open science means something different, and it's a challenge to get aligned on what it is that we're trying to achieve. As I mentioned, the Agile project management took more time and resources than we expected. And this means that open science is not cheap and it's not free. It requires a lot of resources and a lot of time. Development of infrastructure had a high initial cost, but as we are already implementing our infrastructure and GitHub and pages, we're now able to focus more on the content that we're developing. It did have a high cost, but now that cost is quickly reducing. And of course, developing material in Spanish has been proven quite challenging, even using AI, because a lot of these generative text AI languages miss a lot of the context that is needed for these science projects. Or there's a lot of data that is not available in Spanish, so we don't have case studies to show or to provide in that language. So we're trying to apply for a supplement, ROSES, so that we can figure out a way to expedite these translation to Spanish. Thank you very much. I appreciate your time, and I'll have any questions.
Thanks, Juan. We have some time for questions. Yeah, so as a infrastructure service provider myself, lots of the changes in the last couple of years with the federal incentives and requirements for sharing data in particular is great news, because there's lots of activity there that might not be there otherwise. But as you say, providing those kinds of things that are not free or without significant effort. So coming from one of those agencies that's developing your plans for responding to that, what does that look like to you as far as supporting infrastructure that you and your communities are going to rely on?
Yeah, thank you for that question. It's a great question. I think it's a lot, from what we've been hearing from NASA, they're still trying to figure out what the cost analysis is. You know, they're also making a big push towards moving all these large data sets into systems like AWS. And as you know, we've discussed some of the consequences that could have. Right now, what we've been seeing is that just merely trying to design these programs and these curriculum have a very high cost. Initial cost is very high. And that's something that I think was underestimated, especially now that as we're moving into cloud systems, each time someone accesses something from AWS is going to cost some money. So I think from what we've been hearing from NASA is that they're willing to put up the money for it. But how long is that going to be sustainable? It's hard to say, you know, especially with administrations changing. So yeah, it is a bit uncertain, that aspect of this work. So I wish I had a more specific answer for you, but yeah, it's something that they're still continuing to figure out because it is a major concern that keeps getting raised. Yeah.
Just was there, maybe I'll pick back on that. Eric, if you listed out like what are like the key points and stuff that you ran into?
Yeah, so recently we had a meeting with the other science core recipients, and a major part is, it's still NASA. It still appears to be very US based, US centric. So getting support from other agencies, from the European Space Agency or the Japanese Space Agency, they're still reluctant in terms of what open science means to them. So I think that's been one of the biggest challenges, to get support and buy-in from people outside of NASA. People raise national security concerns, funding concerns. So a big challenge has been to find partners that want to do this from Latin America or from Europe. Yeah,